Today I'd like to make some introduction about our work on the optoelectronic agriculture. The first, I'd like to make some introduction about my university. Right now, I work for USTC, University of Science and Technology of China. And also Professor Pei Gang, he's my colleague also in USTC. But I work for the physics school, optical department, and he worked for engineering school. Yeah, so it's okay. My voice is okay.
Yeah, all okay. Go ahead.
It's okay. Okay. Yeah. Good. Yeah. I'd like to make a brief introduction about my university. USTC is a kind of a top 10 university in China. Ranking number one in physics. Optical department also kind of a top department among the optical department in China. Okay. That's our brief introduction about the USTC. Okay, my personally, I thanks Professor Safa over make an introduction of my background. Yeah, and right now I'm kind of a group leader of optoelectronic lab. In our department we have two labs. One is optoelectronic lab. Yeah, we have a project on optoelectronic agriculture. Yeah, there are several PhD, postdocs, PhD, and a number of students. And also we have two senior joined professor, Professor Zhu Xinguang. His expertise is on plant, on agriculture. And also another senior Professor Yang Injinghoff, his expertise on the optoelectronic. The group called Optoelectronic Agriculture is kind of a new R&D subject. Yeah. Actually, actually, we try to do the thing is do the light management, light environment management for the plant. Yeah, this is kind of new. Before that, advanced agriculture technology majorly on DNA management, on the fertilization, those things. Light management is kind of very weak. Not too much control, and we try to do the thing, combine the optoelectronic technology with agriculture together. Yeah, and this is kind of getting more and more attention. Many people involved, gradually. Yeah, involved. Yeah. Let's talking about the motivation of this R&D project. Yeah, the motivation. Yeah, the thing is in China actually. Yeah, in the past 40 years, actually the industry grow very well and double. Yes, but agriculture still kind of far behind. Yeah. Agriculture efficiency is very low, yeah, and lower than average, world average, yeah, that's kind of thing like that. And in China, in the rural area, not too much young people remain in the village, and the young people all go to city. Those things getting more worse and worse. Yeah. So that's the situation now. Yeah. In China, we try to, the government and we try to learn the the world leading agricultural mode from US, from Netherlands, from Japan, from Israel. And there are 6 agricultural modes. Okay. Yeah, we try to learn those advanced mode in China. And it seems the good two model is more attractive for Chinese people, but for Chinese agriculture, yeah, it's one is Israel drip irrigation, this technology. Yeah, the second is Netherlands greenhouse. Yeah, but the reality, these two mode. Not really, we didn't learn very well in China, still not too much improved for Chinese, yeah. So that's the kind of background or motivation of what we try to solve, try to make a new model, yeah. So we do a few things on the optoelectronic agriculture. The first thing is called APV, agrivoltaic. Yeah, this kind of thing actually worldwide did a lot. Yeah, in Japan, in Europe, many countries also did this APV. Just combined photovoltaic technology with the plant grow with agriculture. They call APV. This is kind of very more attention, more and more attention on this area, yeah, and this research, yeah. In China, actually, suddenly we did a lot APV system in China in the last 5 years, yeah. That is because Chinese government combined with APV with a big project, national project called anti-poverty, Fuping. We did a lot of this. According to the report, government report, we already set up 80,000 APV station in China, and total PV install is over 30 gigawatt. Yeah, so it's really a lot. Yeah, and also Chinese government try to introduce APV worldwide, because in China actually. APV combined with poverty, anti-poverty project is actually the effect is pretty good. The farmer is very happy because they get really get income from PV generation. Yeah, but the thing is this is some good yeah, worldwide, not only in China. A lot of APV combined with agriculture. Many countries did many things. One more thing I'd like to say, for the some area water, short of water, if you use APV combined with agriculture, yeah, water evaporation can reduce a lot. So it's a benefit for agriculture. Yeah. But in the reality, I generally say plant not really grow very well under the solar panel. That is because the shadow effect. Yeah. Also, some people did on greenhouse with transparency PV panel. This kind of transparency PV panel. But still, a shadow effect is still very very bad. Yeah, so also no good, not really good for plant growth. Yeah, and our idea actually came from optical fiber communication. For the second generation optical fiber communication, we use one fiber and carried 40 wavelengths. And this is already realized, yes, in practical, running very well. And we can separate 40 wavelengths from one fiber and add these wavelengths and separate these wavelengths. So no problem. Technically, is kind of major technology. Yeah. So we use this technology. We separate the wavelengths from sun radiation. Those necessary for the photosynthesis. Basically, it's blue and right and far right, those wavelengths. So we can use this major technology, optoelectronic technology, separate those wavelengths. And we drop these wavelengths for plant growth, and all the other wavelengths, sun radiation, reflected by a curved glass, then generate the power. So this is a kind of ideally APV system. Yeah. This is we already set up this kind of experimental farm in Anhui, in China, in Anhui, and the results is very good. Yeah, and the plant grow very well, and the productivity actually increased 20%. Yeah. So if you drop the necessary light for plant growth, use the other sun radiation for the PV, then the effect is really even better effect for plant growth. Yeah. So this is already demoed. Yeah. So for light splitting, yeah, we know the technology can use as a prism. Yeah, prism can separate. But what we use is I mentioned this later. Yeah, and this is the picture we grow some plant. The plant grow. This is a comparison. Outdoor and under the solar panels, you can see the plant grow even better than outside. Yeah, this is all remaining light reflected, generated the power. This is actually is a kind of a CPV system. Yeah, the same of a CPV system before. Yeah. Okay. And this design idea has been take a video called Smart China in 2016 take a discovery, make a video in China. Yeah, and they really like this idea, and yeah, the model, they make a broadcasting and promotion this design. Yeah, and we got a award in US, R&D 100. Yeah, it's that's 2017. Yeah. So far, actually, only 4 projects win such honor. Yeah, in China. Yeah. Okay. The key thing, as I mentioned, to separate the wavelengths for photosynthesis, that's the key technology. Yeah, use the prism can done this. And what we use is kind of a low-cost solution. Use plastic film. This is a multi-layer plastic film. Actually two kind of plastic material or polymer material. These two materials, the optical index is different. So if you use a special design and equipment, you can realize such a wavelength drop. Yeah. We in USTC we already set up such a equipment. We design this equipment and we manufacture in China, and we already have sample. Currently, we are looking for new funding to set up a kind of a production line. Yeah. So yeah, okay. We have a second solution for APV. That solution can reduce the shadow effect. Yeah, actually we use a kind of a green lens glass. So it's a kind of typical glass panel, and on the surface of panel we have thinner design surface, so we can separate the light. Solar panel, under the solar panel, the light become uniform, like this picture show, become uniform, and the light intensity increase more than double. Yeah. This is the situation. Yeah. So I have we add a glass with thinner lens on the surface, and under the uniform light, and the light intensity increase double. So this kind of design also can help a lot. The plant also grow much better than before. Yeah, even some plant also increase productivity increased. Yeah, and also we use this idea to do a greenhouse. On the top of the greenhouse, we have a kind of softer solar panel. Solar panel is softer, and we add such kind of thinner plastic film with a thinner surface. Yeah. So this we seeing this greenhouse, the light is uniform. Yeah. And this solution, some results, we will also make a report on agrivoltaic 2021, and this year is coming another conference. Yeah. This PV magazine also make a introduction about our solution. And this also get attention from some African country, yeah, like Sudan. Ambassador, the ambassador visited USDC, and they try to ambassador tried to introduce our technology into Sudan and set up kind of joint lab. Yeah, with we also have a lot of joint project with some enterprise, also in some with international research group. Yeah, university. Yeah. Okay, that's the first thing I already talking about introduction. Yeah. The second thing is really optoelectronic, the major topic of today. Yeah. As you know, in China, we have two actually photovoltaic industry and LED industry is very strong. Yeah, and the price go down a lot. Right now, compared with 5 years ago, is only 10%. The price go down to much cheaper than before. Yeah. So basically, on these two industries, we think we can make a new agriculture model. Yeah. Let briefly say the idea is we use the APV generated power, electricity power, and electricity power we don't use the power to make money but we use the power for the agriculture itself. Yeah, not like before. Poverty, anti-poverty project, we sell the power for money. This is a new model. We use the power for ourselves, for the agriculture, for the rural. Yeah, this is another important concept called plant factory. Yeah, so once we have electricity power, we can grow the vegetable inside the house, and this is a very high efficiency agriculture way. The thing is actually we combine the PV with plant factory. Yeah. Our group, we already did a lot of this kind of R&D work. We have kind of in China, it's kind of advanced technology in China. Yeah. Where with this model, use PV combined with LED plant factory, we think we can meet the 4 target. Yeah, number 1 is double the night efficiency for the plant. and we can make the GDP for the per mode increase double and double. Yeah. Also, water consumption reduce a lot. Also, per person, GDP can increase almost 10 times. Yeah. And this is a kind of, I mean, increase the efficiency, light energy efficiency is kind of a long dream for Chinese people. Yeah, many years, 60 years ago, people think we can make that's kind of a long dream. Yeah. With this new technology, with LED, with PV, I think we can getting close to this target. Yeah. Our optoelectronic prototype, actually, we already set up. We take the advantage. That's a kind of military application. Because they don't short of money. Yeah, they have enough money. We set up a kind of this is a solar panel, solar station, and solar station generate the power, and we supply we call container plant factory. So inside like this, yeah. So grow the vegetable inside the container factory with PV power. PV power generate power for one post we install two. Yeah, we have quite a number of posts on the Chinese Indian border already equipped with such a container. So the soldier have even in the winter they have vegetable. Yeah. And that is the first mode application for optoelectronic. First application. The second one also kind of primary mode that we use for greenhouse. Yeah. Greenhouse. We have a solar panel add, so it's take a part of night for power generate, but we have technology make the night uniform inside the greenhouse. After that, we add some night LED night inside. So when the okay, my time already run out. I will quickly okay. Okay, yeah. So briefly say we use part of PV PV power for LED night in the morning. This is a show. In the morning, in the evening, the sunlight not so strong. We don't make the power generate the power for the grid. No supply outside. We just supply ourselves. So actually, in the morning, in the evening, the light inside the greenhouse become stronger, become better. Yeah. And in the daytime, in the afternoon, sun radiation strong, all light generate the power and make money to sell to the grid. But at this time, daytime, actually the sun radiation is too strong. So we make the inside the greenhouse, the light intensity actually is kind of management, can be average. So it's environment, light environment actually improved. So that we call is kind of light management greenhouse. So this is kind of we saw this kind of advanced mode, advanced greenhouse, even better than Switzerland greenhouse. So it's kind of combined with PV, combined with LED technology. So this is a model we have just this year. This Spring Festival we already set up kind of experiment. It's already started. So far results is it's promising. Yeah. So this is before existing called APV greenhouse. Inside is not so uniform. You can see. So our greenhouse kind of improved. Yeah. Okay. Once again, we try to use optoelectronic industry, good technology, advanced technology to help the agriculture. Yeah. So industry modernization help agriculture development. Yeah, that's basically our idea. Yeah. So we have a roadmap. Yeah, and step by step, we part of us already realized. It seems the concept, it seems right. Yeah. That's all. Yeah. The major. Yeah. Okay. Thank you. Yeah. For the. Yeah.